All right now I want to look at this problem that we've got down here. We're trying to take this general form equation and rewrite it into its standard form so we can figure out what kind of conic it is and what it looks like. So I'm taking a first step here of separating our y and x terms. The reason why I did that is because I'm noticing that we only have a y squared term. We have a first degree or linear x term. So this is telling me that we're going to have some sort of relationship in which one thing is squared and the other thing is not squared. Now if that sounds to you like it's a parabola, you're thinking along the right lines. And I'll show you something in just a minute to understand what this means. But first, let's try to get it into a familiar form for a parabola. So to do that, I'm going to try to complete the square for my y term. So I'm going to rewrite this as y squared minus 6y plus something is equal to 12x plus 3 plus that same thing. And knowing what I know about complete the square, and if you don't, check out the other video on this channel, this term right here should be half of that 6 squared, or 9. That gives me y minus 3 quantity squared is equal to 2x plus 12. So from here, I'm going to solve for x. So to do that, first I'll subtract 12 from both sides. And after that, minus 12. And then I will divide both sides by 2. This will give me, I'm going to just write this as 1/2 y minus 3 squared minus 6 is equal to x. Now, if you were looking at this and the x and the y were switched, it would look like standard vertex form for a parabola. But we have the x and the y switched, and that can be kind of confusing if you've never seen it before. So let's think a little bit more deeply about what this looks like. And to do that, I want to compare these 4 functions. Y equals x squared, y is negative x squared, y squared is equal to x, and negative y squared is equal to x. Now, I know that you already know what y equals x squared looks like, but just for the sake of it, I'm going to plug in something like 0, 1, 2, negative 1, and negative 2 in here. And we see the symmetry between these two. We see a function that's going to look something like this. Similarly, if we went in the negative direction, when we plug in 1 for x, we'll get negative 1 for y. 2 for x gives us negative 4 for y. And the same is true for negative 1 and negative 2. Now I bring up these points because looking at these values will help us think about what something like y squared is equal to x looks like. So again, I'll plug in something at first like 0 in for x. So if x is 0, y squared is 0, which means that y is also 0. But let's think about something like 1. Instead of squaring, now we're thinking about the square root. If x is 1, then y squared is 1, and the square root of 1 is 1. But wouldn't negative 1 work as well? Because if we plug in negative 1 for y, we square it, we get 1 for x. And the same is true for things like 2 and negative 2. When we plug those in for y, they give us the same value in x. So it's the same shape and the same idea, but it's just flipped. And so instead of having an always positive y and positive negative x, now we have an always positive x and positive and negative y. And you can imagine if we make the y negative, we'll simply flip all of that around. So now when we plug in 1 or negative 1 for y into our negative y squared equation, we'll get negative 1 for x. And when we plug in plus or minus 2, we'll get negative 4 for x. There we go. So keeping this in mind, keeping this parent function right here in mind, this parent function that opens to the left, if we look at what we have over here, we have a similar case. We have a y squared term with a positive leading coefficient, so it's not negative, is equal to x, which tells us that this curve is going to look something like this. So now that we know what it looks like, we also know that the directrix for this curve will be to its left, and it will be vertical, so this will be an x is equal to something line, and also that the focus is to the right of this curve because it's inside the parabola. Now all we have to do is follow similar procedures that we would have followed with a familiar upward-facing parabola. For example, if we're trying to find this distance d, we know that d can be given to us using the formula 1 over 4d is equal to our leading coefficient of 1/2. Solving that, we can see that d in this case is also 1/2. It's cool, but a bit of a coincidence. And our vertex, well, let's see. This vertex right here is our leftmost point on this parabola. So it means that it's the smallest value of x. So what is the smallest possible value of x here? Well, this piece right here is always positive, and the smallest possible value for it would be 0. So x is its smallest, the minimum value for x, I'll call this min x, we can find when we have 0 minus 6 is equal to x, or just -6. And when is that true? Well, that's true when this piece of our equation was equal to 0. And this happens when y is equal to 3. And so we can conclude that this vertex point right here, where we have our minimum value of x, is the point -6 for x, comma 3 for y. So from here on out, all we have to do is use that value that we found for d to find our vertex, or to find our focus. So if we move over 1/2 of a step, we'll get the point -5.5, comma 3, which means that our directrix is also 1/2 of a unit away. So that line would be x is equal to -6.5. So adding that to my graph just to make it look all as nice as I can, I'll plot -6, comma 3. 1, 2, 3. And then I will plot my focus point, which is extremely close to it, and our directrix, which is extremely close to it as well. And from here I can sketch in my curve. And there you got it. Altogether, we moved our terms to separate sides, knowing that since we only had one squared term, it would be a parabola. We completed the square and then moved it into our standard form. And then once we realized that our parent function was a left-facing parabola, or parabola that opened to the right, rather, we were able to find the values for d, for the focus, and for the directrix. Hope this made sense. Hope you found it satisfying.